How's it going? Project number 2. This is for EE292, and my name's Dylan Annie. And what we're going to be doing today are experiments 8 through 13 inside of our experiments, and then we're going to do some Arduino experiments as well. Experiment 8 introduces the use of a capacitor, and so what that will do to our LED is it will slowly light our LED up, and then it will slowly dim it once the switch is turned on and off. And the reason for this is because capacitors are kind of a storage unit, and it has charging and discharging properties. So we're going to set up all of our components. Now we don't have any steps to do so, so I set up my breadboard the exact same way it had in the picture with my capacitor set up here. And what we're going to do is just turn on the switch and see what the LED does. So we notice it takes a second to turn all the way on, and then when I let go of the switch, it slowly dims. And that's all because of the use of the capacitor. So that's experiment number 8. Experiment number 13 talks about one-way light bulbs. So what we're doing is we have 2 LEDs set up, and they're actually going to be in opposite directions. And so we know that since these are diodes, since they're in opposite direction, if I have energy flowing through, let's say, this loose wire, this LED will receive the energy, but this one will not, since it's in the opposite direction. But then if I connect the energy from the capacitor that we have set up to this loose wire, now this LED will light up and this will not, because obviously it's going in the opposite direction. So what we're going to do is connect our positive to this first loose wire, and notice it lights up very quickly, and then it dims down because the capacitor is storing all of that energy. So now that the capacitor has that energy, we're going to click on the other light, or the other wire, and notice that the other LED lights up. Slowly dims because now all the energy is passed. And those are the first 8 through 13 experiments. Experiment 9 talks about when we have capacitors in series. So normally, our normal assumption is, especially with resistors in series, is that the resistance is stronger, and therefore our light is going to be dimmer when they're in series. But in this case, the capacitors kind of act like parallel resistors. And so their relationship's the same. It's their product over their sum, and it actually yields a smaller capacitance. And what this will do is it basically will light up our LED quicker. So our previous experiment, we had a bigger capacitor, and so what that did is it grabbed hold of the energy a little more. So now, since there's going to be kind of less capacitance, when it turns on, it'll turn on a lot quicker, and then it will dim much quicker as well. Experiment number 10 talks about the capacitors now in parallel. And so, just kind of like the opposite of resistors, when they're in parallel now, we're going to add the capacitance. So now it'll be, we have 100 and we have a 10 capacitance, so now we'll have 110. And what this will do is obviously from experiment 8, our light it'll light up and get dimmer now at a slower rate than originally in our when we just had the 100 one. So now when I turn it on, notice it takes a minute to light up, and then when I turn it off, it takes a long time to dim out. And that's capacitors in parallel. Experiment 10 was really interesting because I'm making my own battery, which is something that I've never done before. And the way we can do this is just by using a capacitor. So what I'm basically going to do is we have these unconnected wires. One wire is connected basically to our battery. It's our positive end of our battery. And then the other one is connected to our capacitor. So what I'm going to do over here is touch the positive one with the loose wire that's connected to the capacitor. And when I make that touch, right there, the capacitor just took all of that energy in, and now it's stored within the capacitor. So what I can do now is touch my connection of the capacitor to this resistor, and it'll flow into the LED. It'll be a lot of energy very quickly, and then it'll slowly diminish. Just like that. And now all of the energy in the capacitor is gone. And so it had all this energy, and then it got rid of it, and that was experiment number 11, which is just making my own battery. Experiment number 12 talks about one-way currents, and the way we're going to kind of show that current is using two diodes. So we already know our LED, our light-emitting diode, and now we're going to introduce another diode. And so as of right now, we have both of our diodes in the same direction, so therefore when we turn on the switch, the LED lights up. And that's because this diode here is allowing the current to flow in that direction to this LED. So now what we're going to do is reverse the order. So now I know this diode is now saying, okay, I want to stop the current in this direction because this one's now in the opposite direction. So when I click the switch, it doesn't even turn on. And that's because this diode here is blocking the current from letting it in. And that's experiment number 12. The next part of our experiment, or for project number 2, was the rest of the basics for Arduino, but we cannot do the first one because it needs a potentiometer, and that was actually not included in our kit. So we're just going to go on to do the bare minimum, the digital read serial, fade, and read analog voltage. The next experiment that we're doing for project 2 is the digital read serial. So what we're doing is we're basically, we're going to set up a switch, and when that switch is not being pressed, the computer is going to read a bunch of zeros, basically saying, okay, it's off. And then when I click the button on, it'll read a bunch of ones that says, hey, look, it's on. So the way we set it up is we set up our switch and all these wires and connections and a resistor to our Arduino and our breadboard. And notice here it has an Arduino DC Milia, and we have the Arduino Uno, so it was a little different of a setup, but I think I figured it out. And what we did is we ran the code, so basically inputted this code into our Arduino software. We uploaded it, and now we're going to read the serial monitor. So the serial monitor is basically this just list of zeros. So right now it's saying, hey, look, we're not pressing the button. So when I do press the button and I hold it, now it reads a bunch of ones, and then when I let go of it right now, it's all zeros. Ones, zeros, ones, zeros. And that was our digital read serial. The bare minimum is literally just talking about our circuit and how our Arduino works. And basically we have our circuit, which is plugged in here, and we can code stuff onto it by using the setup, and we can also use the loop function to basically tell Arduino to do whatever we want. For the next experiment, we're doing a fade, so we're going to make our LED fade on and off. And the way we're going to do that is by plugging in our Arduino, setting up all of the connections to our breadboard, and then running the code. So I will now run the code and upload it to my Arduino, which is currently off. And we'll see what the LED does. So it's now uploaded, and our Arduino is fading on and off. And that is fade. The last experiment we were supposed to do is read analog voltage, and the only way we could do that is with a multimeter, which we again do not have. So that would be project number 2 for EE292, and my name is Dylan Nanny, and I can't wait for project number 3.